logic gate. In this video, I just want to touch a little bit on logical gate, which is about the introduction, what you're going to learn on the logic gate, and etc. So here is the outline for the logic. This is basically my old slide, so I just want to share it first. Later on I will also reproduce another video just to touch on logic gate. It's very good if you have more resources, more video, although it is a similar topic. So over here basically we have basic gates, universal gate, and also others. So the basic gate you need to know first is NOT gate, which is also known as the inverter. And then you have the AND gate, and another one is NOR gate. So these three gate is the basic gate. You need to know the basic before you can go to the master level. And then there is the universal logic gate. What is the universal gate? Is NAND gate. NAND gate is basically the combination of AND with the NOT gate. So NOT plus AND gate. And then another universal gate is NOR gate. NOR is the combination of the gate NOT with the OR gate. So later you will learn on this, but the basic one, please get familiar and understand carefully NOT and OR gate. And others gate is on exclusive OR and also exclusive NOR, XOR or XNOR. So let's move to the basic one. Before you go into the basic, you need to know what is logic gate. So logic gate is basically electronic circuit that manipulate the voltage on the voltages. So in fact they manipulate the binary 1 and 0, because computer is basically play on the programming which is related the language of the binary, which is 1010, and moving around inside your computer. Of course, logic gate in which they can combine together are therefore essentials to making a digital computer work. So here the first basic logic gate that you need to know is NOR gate. So you can see this is the symbols of NOT gate. NOT, same goes to don't, not, I, not, let's say like that. So NOT is same goes to don't, like that. It is negative verbs. So you have the input and also output over here. This is the input side, and this one is the output side, and this is the symbol. So if let's take a look into what happened to the input that given. Let's say you have 1 as the input over here, and that what is going to be the output is going to be a 0. And let's say you have the input, different input, which is 0, your output will become as 1. So it can be said as invert, because if you check the truth table, you can see over here the truth tables, you have the A as input, This one is A, and then the B is as the output. So every time you have A or input 1, or also you can have it as high or you on, so the output will become low or off. So this is if, let's say, you have the input 1, but if your input here is 0, so your output will become as 1 or high or also on. So this is about NOT GET, very basic, because you have two possibility only, because you have one input which is A, you have one input and one output. So the symbol is one input and one output. So two possibility, 0 and 1, and the output is the inverse from the input. So here I summarize it all together. On the symbols, you can see this is the symbol. Please memorize, please understand the symbols, because later on you will always use these symbols with the combinations of other kids. And about the characteristic, it's pulled from the inverse or complementations, which is it changes the logic level to the opposite, from low to high or from high to low. So this is the truth table. Simple, so quite easy to you for understand and memorize it. So how the operator look like, the operations of NOT gate. So if you have a NOT gate, you will have the A bar or NOT A. It means that A is the input. So everything is, this one is, let's say you have A, so your as the input, so your output will be as A bar. So this is just operations view of the NOT gate. And then about logic expressions, over here quite similar to mine, which is you have the A as input and your output will become A bar. So X is the complements of A. AX over here is your output. Last time I called it as B, so don't confuse, because everything over here we call is as output. We just use this as a symbol of output, whether it's B, C, D and everything. So as long as it is here, it is output, and if it is here, we call it as input. So the output here is the inverse of the input. So sometimes you quite confused with the A, B, C or X, so just ignore it, but you name it as input is the complements of the the output is a complementations of the input. The output is the inverse of the input. The output is not the input. So quite easy to understand the NOT gate. Now we move to the AND gate. So when you play around with AND gate, you already increase another input. For the NOT, you have one input, but for the AND gate, you have two input, which is input A, input B, or maybe input 1, input 2, or maybe you can name it as input X, input Y, anything on the labeling over here, but it is input. And over here you have the output. So you must have input and output for any type of gate. Depend on how the gates look like. For the AND, you have two input over here. So let's take a look into the examples. If let's say you have input 0 and also 0, the possibility if you have two input, you have to the power of n, isn't it? I forgot the mathematic form, but please ignore first, because the truth tables you're going to have the possibility of 4 to the power of n. You have 4. So over here you have 0 as the input, and then you're going to have 0 1, and then 1 0, and then 1 1. So this is only 4 possibility if you have two input. And what is on the output? So the output of course it's only 1 over here. So if let's say 0 0, what you're going to get if it is AND gate, it is like you multiple it. If you multiple with any number with 0, what you're going to get, it's still as a 0 times. And then over here, if let's say you have another example which is on 0 1, so what you're going to get is 0 as the output. And if let's say you have 1 0 as the input, you also will get remain 0 as the output. And lastly, if you have 1 1 for the input, then the output change to 1. So over here I show you the truth table. You have A, B as the input, and then the output over here. And if let's say it is 0 0, you get the output of 0, and then 0 1, you have the output of 0 also, 1 0 also 0, and only you have all high, which is 1 1 or on, then you can get high also. For the rest will be 0 or lower. So how to conclude it? I conclude it like this. So this is the symbol. I hope you're going to remember this because it will look like as D. For me it look like D. And then you have two input and one output. So it's quite easy to remember, of course. And about the characteristic, as I mentioned, is a logical multiplications. How you're going to perform your multiplication is like this on dotted over here. So if all input is high, then you get the output of high. For the rest, you're going to get low as your output. So this is your truth table for the AND gate. I already showed it in the previous slide. And over here, AND gate must have at least two input. So if you have, let's say this is another example, you have this as output, and let's say you have like this still as AND gate, because you mentions over here it must have at least 2. So you can have 3 input, 4 input, 5 input, as long as the symbol is look like D over here and get one output. You must have one output like this, that it is AND gate. AND gate can have more than two input, so that's why I mentioned over here, if let's say you have 7, let me draw clear, let's say I clear first. Okay, this is normal or simplest AND gate, but it mentioned here you must have at least two, and you can have more than two input. So if let's say you have this kind of gate, this is also called as AND gate, because it have, let's say over here, 5 input but 1 output only, so it known as AND gate. Is it okay? So let's move to another, which is OR gate. OR gate is look like this. Normally I just draw like this. It's look like a moon, and of course I have 2 input and 1 output, and I told you this is just labeling. You can have the input 1, input 2, or input X, input Y, and the output is Z, or the output is 3, or the output is Z, depend. Only that what you need to know is you have 2 input and 1 output. So let's take a look. If let's say we have the possibility of input, which is 0 0, the output will be 0, and then if let's say we have 0 1, the output is 1. If let's say we have 1 0, we have 1, and if let's say we have 1 1, still the output will remain 1. So the truth table look like this, which is you only have the lower output if let's say both input is 0. So I can say it's quite similar to add, it's not multiple, so they are adding process in mathematics. You add 0 0, you get 0, you add 0 plus 1, you get 1, and etc. So I summarize it like this. So this is the symbol, and then as I mentioned in the AND gate, you can also have multiple input and you have 1 output. Still it is OR gate as long as the symbol is correct. It's look like a moon, the moon. So over here the characteristic is performed of logical adding additionals, which is you add, and then if any input are high, any like this, as long as you have high, then you will get high, and you will get low only when both input or all inputs are 0. So the Boolean expression is look like this: A plus B, or it can be also X plus Y. It's depend on your on your labeling in here. So finish on the OR gate. Let's take a look into another gate. Basically this is the combination gate, as I mentioned previously, on your NOT gate and also AND gate. So this is exclusive gate, isn't it? So for this gate, you can see you have quite similar to AND gate, but you have these circles or bubble over here. So let me draw it, it will be like this. So you have one input for NOT and output for NOT, one output for AND gate, two input for AND gate. So full requirement. So this is how it's representing of your AND gate. So what about the truth table? Before we go to the truth table, let's have a look into the possibility of the truth table. What's going to happen if, let's say, you have 0 0, you have it as the output of 1, and then if, let's say, 0 1 is going to have 1 also, and then 1 0 is 1, and lastly it will change to 0 if all the input is 1. So this is how the truth table look like. So you can see it, the inverse of the AND logic gate. So now over here you can see that the possibility of 0 0, what you're going to get the output, and then 0 1 you get 1, 1 0 you get 1, 1 1 you get 0. So this is the possibility, and how it look like basically is like this. If you have A, B, and then you get the output as A, B bar, you need to check it carefully over here. It is A, B, of course you have the multiple over here, A, B, which is this one, this AND gate, and the bar is NOT gate. I repeat, dot over here without the bar is the AND gate, and if you have bar is NOT gate over here, so all together you get as the NAND gate. But please make sure and carefully, A dot B, if you have this kind of symbols, is not similar to this. This is A bar multiple or dot it to B bar. So how it's going to look like, I give you the example. So I erase first. Let's say you have A bar dot B bar, you will have like this: A, this is A bar, and then you have another input, which is this one is B, you will have the output as B bar, and this together you will multiply using the AND gate and you get the output. This represent as this one, and not similar to this one, totally not same. You can see the representations of this like this, and A bar dot B bar is like this. So please make sure you see carefully on the bar over here. So I just give you examples of NAND gate first, and you can see the truth tables and the symbols and the expressions, as I also mentioned. Please carefully with this and this. So, and then about the characteristic also, you can just read it, because it is just the inverse of AND gate. You can see over here, NAND is not AND combination, which is AND and also the inverse. That's why it is the inversions of AND gate. I give you the example of this, and I'm not going to show you basically on NOT OR, which is NOT OR, which is combination between or and also not get. So this is how I conclude on the not, nan, and or. So others logic get I will share it on our next video. So I hope you understand all these symbols of these truth tables and how it basically works. Is it okay? So until then, thank you for watching this video, and we meet again in another class and or in another video. Thank you.